All right, let's get going here. We're taking a look at the next chapter in our Forces in Motion unit. If you click down here, you can see that we've finished using vectors and scalars, and now we're moving to solving motion problems. Okay, so let's go ahead and draw our lines here. Make sure you put the date. And as always, setting up our notes here using the Cornell note template. Our essential question is going to be in green here. There's 6 explore pages. We're on the first one. How does an object's speed affect the distance it travels in time? How does an object's speed affect the distance it travels in time? Okay, what do you know? Okay, go ahead and take a moment, hit pause on the video, and write just a few bullet points or perhaps a sentence or two. Remember, this is kind of activating your brain, trying to get you to be actively engaged in the learning here, right? Okay, so as we take a look here on the left, what is speed? Roman numeral 1. It is a measure of how fast an object is moving, right? My car speed, according to the police officer, was 100 miles per hour. That's how fast my car was moving. Speed, right? Scalar, right? There's no particular directionality that we're talking of here. So speed is a measure of how fast an object is moving. Okay. Now, second sentence here, faster moving objects cover a greater distance than do slower moving objects in the same amount of time. Speed, therefore, is the rate at which distance is traveled. Speed is the rate at which distance is traveled. Now, when you hear the word rate, you should already be thinking of things like ratios, right? Think ratio. A ratio would be like a fraction, right? Or it could be this would be a ratio here, a 1-to-1, or we could say a 1-to-2, right? We have a fraction kind of thing going on there. Okay, more on that, but I just want you to think about the idea of ratios and how we represent things. Okay, so what are average speed and constant speed? I may drive from home to work at a constant speed of 70 miles an hour. Maybe I drive half of the distance at 50 miles an hour, and the other half of it at 80 miles an hour, and the average works out to 70. So average and constant speed are different things. Okay. So let's see here. I'm going to pull up my pen here, and I'm going to drop down here. The speed at a particular instant in time is the car's instantaneous speed. A more accurate picture of how fast a car is going over a period of time can be found using versus average speed. So we have two different concepts here that they're trying to convey here, right? So let's go ahead and write that down. We have average speed versus instantaneous versus constant speeds, right? Huh. Interesting, huh? So let's go back over here and let's just get some working definitions here, okay? The rate of motion of an object at a point in time. That's instant speed. So we're going to say instantaneous is the rate of motion of an object at a point in time. At exactly 7:32 a.m., Mr. Meyer's instantaneous speed was 82 miles per hour at a point in time, right? Versus, say, average speed. What is average speed? The distance traveled by an object divided by time, by the time it traveled. Okay. Let's write this down. The distance traveled by an object divided by the time it traveled. Okay. And that almost looks like we could set that up as a formula right there. The speed is the distance divided by the time. Okay. And let's go back over here. And is there anything else that we can add here? Make sure you watch the videos. Okay. Sometimes objects travel at the same speed over a period of time. In this case, the speed is constant. Okay, I don't know why that just changed there, but we'll write that down over here. Okay, let's just pick a different color. When an object travels at the same speed over a period of time. Okay, so if we jump down to the, and they'll give you some examples here. Make sure you are reading the text. You can see I've got this highlighted here. When an object is moving at a constant speed, its instantaneous speed at any moment is the same as its constant speed. Likewise, its average speed is equal to the constant speed, and therefore the instantaneous speed at any moment. Okay, that's an interesting relationship. Um, clear the screen there. Let's just say I'm going to have to write with my finger here. And let's say this is a well, we'll just write it over here, okay? When an object is moving at a constant speed, then we could say the relationship is something like this. The constant speed will be equal to the instantaneous speed which will be equal to the average speed. Okay, that holds only when the object is moving at a constant speed. Do we see that all of these values would be equal? Okay. All right. Moving on here. So how do you calculate the average speed? Well, speed is simply the rate at which an object is covering distance. Therefore, the average speed of an object can be determined by finding the total distance traveled in a particular amount of time. I think we established that already, right? That was that formula up there, right? So let's just take this guy here and let's just drop him down here. And let's just go ahead and just write a note here. Calculations involving speed. I think that formula is pretty straightforward. I think what hopefully you are starting to understand is that we can rearrange that formula to solve for any one of those variables if the other two variables are given. Okay, so let's just make that, let's write a little note to ourselves. We can solve for any one of the three variables if at least two of the variables are defined. Defined means that they actually have a value. So I'll go ahead and just show you how we do that just as a refresher. We could take the speed equals distance divided by time. If we want to solve for time, then we would just go ahead and cross cancel. What you do to one side, you do to the other. So now what we have is our formula is Oh, I messed that up. I actually solved for distance just now there. Okay, so if we want to solve for distance, so now our formula is distance equals time multiplied times speed. Okay, now let's do the time now. If we want to solve for time, dot, 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 then let's take our formula again. Okay, if we have, I'll use, again, our formula, speed equals distance over time. So now in this case here, we need to get the t all by itself. I would guess that probably, well, let's just do it this way, okay? This will be 2 steps here. I'm gonna take this, multiply that. I'm gonna get the t over here. So now I have t s equals d. And now I'm going to divide out the s. This cancels. What you do one side, you do to the other. So now what I have is I have t equals distance divided by s. And now we're solving for time. Okay, so here we are solving for time. And up here, we were solving for distance. And of course, over here, this one was solving for speed, our initial formula. Okay, so make sure you remember that formula, speed equals distance divided by time. Okay, and that's going to be really helpful for you in working out your problems there. And they kind of just go through here and kind of show you some sample problems and how to do the rearranging of formulas. All right, well, that was short and sweet. I hope that worked out well for you. Let's go ahead and just draw our lines down, okay? Kind of should have drawn those down a little bit there to kind of guide me. Huh? It's getting a little messy here. And let's just go ahead and just end our notes with a summary paragraph. All right, talk to you later. Bye-bye.